Okay, we're going to talk about problem-solving questions, and specifically this process. This process is going to be really useful for you whenever you have to write an equation. It asks you to write an equation and solve it. And there's going to be a test question about how to write this type of equation. Okay? So, first of all, let's go through this procedure. This model drawing is going to help you to write an equation when you need to. First, you should always read the problem through and then reread it to look at, because once you get to the end of the problem, it usually gives the question at the end, what it is that you're trying to solve. And so many times you have to go through and reread it in order to pick out the important information to help you solve it. Then you should write an answer statement. The answer statement is going to help you pick out the right label for your answer. Okay? Then draw and label a diagram. Now, sometimes your diagram works with putting numbers from the problem and using boxes to represent the quantities. Other times you have to draw a diagram that is just a picture of the type of problem that you're solving. So if it says you're building a garden, you draw a rectangle, like a garden. If it says that you are traveling a certain distance to school and then to the library and then back home, and you draw that like a map. Okay? Sometimes those types of problems require just pictures of the problem. But sometimes you're comparing quantities. And then this method works the best. In comparing quantities, you draw a box to represent how much that is. And then you put two boxes together, or you draw boxes that are one on top of the other in order to show the difference between the boxes. And then label the boxes with the numbers from the problem. So, open up your books to page 168. We're going to go through a problem together. Problem's number 5. And I want you to copy this into your notes because this is the type of problem that you're going to have to do on tests and quizzes, on questions for next year's algebra, for algebra class next year. So, let's read the problem first, and then reread it and put some numbers on a diagram. So first it says, to accommodate a wheelchair, a builder installed countertops that are 7,500 feet lower than the original ones. The new countertops are 2.5 feet high. How high were the original countertops? Okay, so what are we looking for? What's the answer statement?
The old countertops are blank.
Right, the old countertops, or the original countertops. The height of the original countertops, right? So let's go back and reread that again. And look for information about the old countertops compared to the new countertops. And why don't you start drawing a model of boxes that you think would work to compare these numbers. Okay? So, to accommodate a wheelchair, a builder installed countertops that are 7,500 feet lower than the original ones. The new countertops are 2.5 feet high. How high are the original countertops? Now, if you had to write an equation for this problem, you would have to use a variable. Right? What are we looking for? The original countertop height. Right? That's what we don't know. So OC, we don't want to use O because that looks like a 0, so let's use what? C for the countertop height. Okay? So you should write that. C equals countertop. The original countertop. Now, what do we know from the problem? What other numbers are in the problem? Kira.
Well, that the new countertops are 0.75, or 75 hundredths feet lower than the original.
Okay, the new ones are 0.75 feet lower or less than the old ones. So the old ones are bigger, right?
Yeah.
The old ones are bigger. So we'll draw a bigger box to represent the older ones. And how much bigger? How much bigger are they? Look at the numbers. Let's go back in the problem. What is it, Michael?
0.75.
So what part represents 0.75 feet? This part? This is 0.75 feet.
Wouldn't it be a negative?
Okay, or this space here, we can also put that as 0.75 feet. What else do we know? Page 168. What else do we know from the problem? James? The new countertop is 2.5 feet high? Is that right? Okay. So this one is 2.5 feet, right? And how far was, we're looking for how long this one is, right? So this is C, right? So now, how could we write this out in a math sentence? Lydia?
You have to add 2.5 feet to 0.75. That plus the 0.75.
Equals C.
Right. Does that make sense? This point, the new one we know is 2.5 feet. And that was 0.75 feet lower or less than the old one. So these two parts together equal the height of the old one. Then put the numbers together. Put the parts together. What is it?
3.
Troy?
3.25 hundred, like 3.25 feet long.
Right.
Oh, I
3 and 25 hundredths.
Oh, you do
Really?
Yep.
I do it.
Oh my God.
Does that make sense?
Yeah.
Okay. Now, if you just read that over, since it says lower, you might think, oh, I need to subtract these. But when you put it on a diagram, you see, oh, wait a minute. The new one is 2.5 feet. That's why it's so important to label your boxes. When you put it on the drawing, you can see, oh, wait a second. These two equal the height of the old one. Okay? So make sure that's how you should use those problem-solving boxes to compare numbers and to identify with a variable what it is that you're looking for. Then you can put the variable in that math sentence and you can write an equation. All right? Here we go.